You may well have heard of our next pattern, the singleton pattern. The singleton pattern is probably the most used single design pattern, and it's probably also the simplest. So our app needs a single instance of an object throughout the app. We might need it for an exception logging manager, so that we only have one class that deals with a single text file or whatever format we're logging into. We don't want to have a lot of conflicts in attempting to write to that logging manager through a multi-threaded app. We might have database or business layer managers that the rest of the application needs to use, but we certainly don't want to create a whole lot of instances of those. They could be very heavy, and there's no need for them to have different instances. We're only really talking to one database or one business layer. Also, if we're using hardware access, for instance, we're calling up a TCP socket or a serial port, well, there's only one of those, so we better not try to access it from multiple places. We'll end up with busy errors or collisions, basically bad stuff. So the singleton is a really simple pattern, and it's really commonly used, and you may well be aware of it already. It'll create us a single instance of an object, and only one instance of an object, and we can call that throughout our application. It does that by actually storing the single instance in a static private member. And it has a private constructor, so the rest of the application cannot call a constructor on it. Then it provides a public instance property that returns the static private instance. That could also be a getInstance method. I've seen it done both ways. I'm not sure that it makes a big difference in C# as to which you use. I kind of actually prefer the property just because of the way the code looks throughout the application in using that property. So in our example, we want an exception handler class. So anytime we have an exception during an application, we want to use this exception handler class. And for our example, we'll just write to a single log file. But there could be a lot of other things that an exception handler does as well. It could actually manage the display of the error to the user, do translations for error messages, write to log files, write to Windows event logs, write to the database if the logging is done there. There's a lot of things that you could do within an exception handler class. No matter, we need a singleton for that because we really only want one central area to handle our exceptions for our application. In our case, we're just going to write to the single log file, and as I mentioned before, we'll have a private static instance member, and that will be, of course, exception handler class type. We'll also have a private constructor, so it won't be able to be called throughout the application. And then we'll have our public instance property, which again will be of type exception handler. And the exception handler will have a single method, writeException, and that will, of course, be a public method, and that's what we'll be using within our application. And here's our class diagram. The exception handler is over on the left, and you can see the private fields. We have the instance field. We also have a lock object that we're going to use to make our instance property thread safe. And we have the stream writer that we're going to use to actually write the exception log. We have methods, and as you can see, the first is the exception handler constructor, and it's private. And we also have writeException log, which is public. Then in our example, we'll have a couple of forms, and they'll have buttons on each called do something bad. So they'll throw an exception, and then we'll have the exception handler handle it. And then form 1 will be able to go to form 2, so we'll be able to see that both of these forms get the same instance of the exception handler, and it works just fine. So that's the singleton, probably the simplest pattern you'll ever see.